Yeah, good morning. I am Afolabi Said Omatunde, Director Access Point. Good day, everyone. It is Access Point Academy video lecture series, and today we want to unravel the concept that has to do with isotopy. Okay, so now, what is isotopy? Isotopy is a phenomenon whereby atoms, exhibit the same atomic number but different mass number due to difference in neutron number. Okay, now the phenomenon whereby an atom exhibits the same atomic number but different mass number due to difference in the number of neutron. So atomic number is also known as the number of proton. So now isotopy will occur in an element, that exhibit the same number of proton but different mass number. Now we can also give it another definition. It can also be defined as the phenomenon whereby atom of an element has the same chemical properties but different physical properties. Okay, so now a situation whereby an atom exhibit the same chemical property. Carbon, for instance, exhibit a certain chemical property which is common to all carbon isotopes, but meanwhile the physical properties varies, in usage and in any other things. So now those atoms that exhibit isotopy are called isotopes. So we're going to give examples. Example is nitrogen. We have nitrogen that has a proton of 1 and a mass of 1. There is another hydrogen that has a proton of 1 and a mass number of 2, and another hydrogen that has a proton of 1 and a mass of 3. So this is called protium, while this is called deuterium, and this is called tritium rather. Tritium. Okay, so now the second example is nitrogen. We have nitrogen 14 and nitrogen 16. So nitrogen also exhibit the phenomenon of isotopy. So now an isotope is this, and this is another isotope. So this has a mass of 14, while this has a mass of 16. Now another is oxygen. Oxygen also exhibits the phenomenon known as the isotopy. So now we have oxygen 16 and oxygen 18. So the proton number, which is also known as the atomic number for oxygen, is 8. Okay, then chlorine is also another example that exhibits isotopy. So we have chlorine 35 and chlorine 37. So what is common to the two of them is the atomic number, which is 17 and then 17. So uranium is also another example. Uranium, which is radioactive, as we have uranium 236 and uranium 238. So they have one thing in common, which is the proton number, which is also known as the atomic number. Then also lithium also exhibits isotopy. So now don't forget, we said isotopy is the phenomenon whereby an atom exhibits the same number of proton but different mass number due to difference in neutron number. So now we also gave another definition, and we define it as a phenomenon whereby atom of an element has the same chemical property but different physical properties. So atoms that exhibit isotopy are known as isotope. So that we unraveled. Now we want to explain the relationship that actually exists between relative atomic mass, of an element. So relative atomic mass is written as R.A.M. Okay, so there is a kind of relationship between relative atomic mass and isotopy. Okay, so now the relative atomic mass of an element which exhibit isotopy is the average mass of its various atoms. Okay, so now for instance, look at lithium. For instance, the percentage of this on the Earth's crust will vary from this. will be different from this. So if this appear probably, let's say 70%, okay, and this one will appear on the hard cross, say 60%, for instance. That is an illustration, okay. So we can use their relative abundance to calculate the relative molecular mass. So now, how do we do that? Now, to get the relative atomic mass that shows relationship between R.A.M and isotopy. So the R.A.M, relative atomic mass of an element, say Y, okay, is the percentage abundance of Y, okay, percentage abundance of Y multiplied by the mass number of Y plus another percentage abundance of the same element of Y, okay, multiplied by its mass too. So the mass is very, very prominent. Now let's take a look at these examples. Let's unravel this question. Now this question, there is a question here that says an element X has two isotopes of X 1020 and X 1022. Now the relative abundance of X 1020 is 25%, while X 1022 is 75%. So what is the relative atomic mass of element X? So now, solution to that glorious question. So how do we do that? Now the question reads again that an element X has two isotopes of X 20 10. So the abundance of that is 25%. So it's given as 25%. And the second one, X, second atom X 20 10 as well. So the relative abundance is 75%. So we have to calculate the relative atomic mass known as the R.A.M. So how do we do that? Now in the equation given above, so this is going to be the percentage by mass of X, okay. So what is the percentage of X 20? It is 25%. So that will be 25 divided by 100 multiplied by the mass number. The mass number is written up excuse me please, as the superscript. That's multiplied by 20 over 1 plus, don't forget the formula given above there. So now for the second isotope, so we have, which is 75%, so you're gonna write 75 over 100 multiplied by its own mass. Its own mass is 22, don't do mistake, 22, okay. So multiply by 22. So here what do we get? We have that R.A.M, which is equal 0.25, okay, that is 25 divided by 100, that's 0.25 multiplied by 20 plus 75 divided by 100, that is 0.75 multiplied by 22. So now I'm multiplying 0.25 by 20, we got 5, then 0.75 multiplied by 22, so that is 16.5. So when we had 16.5 to 16 to 5, so we got 21.5 as our R.A.M. So that is the relative atomic mass of that element X, okay. That is a relative atomic mass of the element X. Now we still got another question here, and the question says and I read, an element Z contain 90% of Z816 and 10% of Z818. Its relative atomic mass is, so we don't know the relative atomic mass, so we have to calculate that. So how do we calculate the relative atomic mass? So now Z168, the relative abundance has been given to be 90%, and then Z6 8, the abundance has been given to be 10%. So we are asked to calculate the relative atomic mass. So following the same method as used above, so R.A.M will therefore be equal 90 divided by 100 multiplied by the mass of the Z of this, so that is 16, then a big plus 10 divided by 100 multiplied by, okay, its own mass as given is 18, so multiply by 18. So 90 divided by 100, that is 0.9 multiplied by 16 plus 10 divided by 100, that is 0.1 multiplied by 18. So now when I multiply 0.9 by 16, so I got 14.4 plus 0.1 multiplied by 18, that is 1.8. So therefore, on adding 14.4 and 1.8, so that is 16.2. So that is the relative atomic mass of the atom X. Okay, so I hope that is clear. Good. Now to the next question, and the next question says the relative atomic mass of a naturally occurring lithium consisting of 90% lithium 37 and 10% lithium 36 is. Yet again we are asked to calculate R.A.M, okay, for lithium. So now unknown, sorry, I have to write solution to separate it from the question. Now the percentage by mass of lithium 73 has been given to be 90%, and lithium 36, its own percentage has been given to be 10%. So now you are asked to calculate the R.A.M. So to get the R.A.M, what do we have? You're going to divide 90 by 100, that is the percentage, multiply by 7, the mass. You don't have anything to do with the atomic number. No, you have things to do with the mass number only. So this is 10 divided by 100 multiplied by 6 over 1 as well. So 90 divided by 100, that is 0.9 multiplied by 7 plus 0.1 multiplied by 6. So therefore R.A.M will therefore be equal to 0.7 multiplied by 7, that on my calculator is 6.3 plus 0.1 multiplied by 6, that is 0.6. So 0.6 plus 6.3, so that results to 6.9. so that is the relative atomic mass of the atom. Now here we have another question which says an element X with relative atomic mass 16.2 contains two isotopes, X16 8 with relative abundance of 90% and XM8 with relative abundance of 10%. The value of M is, so now solution to that question. So how do we solve that? Now here we are already given the relative atomic mass and the relative atomic mass has been measured to be 16.2. Now we are given the relative abundance of an atom X16.8 to be 90% and atom M8 the relative abundance has been given to be 10%. Do not forget we are asked to calculate the value of M. That is what the question asks us to calculate. M. Excuse me, please. So now, how do we get M? So we write the relative atomic mass, which is 16.2. Okay, the relative abundance of that is 19 divided by 100 multiplied by its mass, which is 16, plus the 10%, which is 10 over that, multiplied by its mass. Okay, so what do we have here? We have 16.2 equal to 0.9 multiplied by 16 plus 0.1 multiplied by M. That is that. So now we have 16.2 equals 0.9 multiplied by 16. So that gave us 14.4, okay, plus 0.1 M. So now 16.2 we collect like terms minus 14.4 equals 0.1. So 16.2 minus 14.4, so that is 1.8 equals 0.1 M. So we divide both sides by 0.1, 0.1. So this cancel out this, and our M is equals 1.8 divided by 0.1. So M, which is the mass of X, has been given to be 18. So that is it.